Good morning, everyone. We're now going to switch gears and hear from entrepreneurs in the Stanford ecosystem, hoping to disrupt the status quo and one day be sitting on the stage telling their success stories. We're going to keep this fast-paced, so each company will have 3 minutes to share their pitch, and afterwards you'll all be able to meet and mingle with those companies at the StartUp Open House. We've organized our 24 startups into 6 categories. So this morning we're going to hear from startups in the electricity space, and then the hydrogen space, and then in agriculture. And this afternoon, we're going to hear from startups working on buildings, manufacturing, and transportation. I am here. Jimmy gave me the job of keeping everyone on track. So I will keep this moving. Speakers, I'm going to be sitting at this table here. If you see me stand up, that's your cue to wrap it up. One more sentence. So buckle your seatbelts, and please join me in welcoming our first company in the electricity category, Enervenue.
All right, thank you, Stanford team, for the invitation to present today. To give you a little background on Enervenue, my name is Brad Dory. I'm the Senior Director of Marketing with Enervenue, and I'm here to talk a little bit about our groundbreaking stationary energy storage technology. Now, this storage technology comes with a background from NASA. It was used, nickel hydrogen batteries were used in a number of high-profile applications in the 1980s, including the Hubble Space Telescope and the International Space Station. And in 2017, Stanford University, led by Dr. Shui, reevaluated that technology. And what they did is they pulled out the expensive platinum in that material, and they substituted a lower-cost alloy, and found that not only could they improve the performance of that original design, but they could do so with a lower cost profile and line of sight to a lower cost profile than today's lithium-ion solutions. And with that, in 2020, Enervenue was born and spun out to commercialize the technology. And today, we're participating in the grid scale and commercial and industrial markets, supplying the market with energy storage technologies. And a little bit about our solution that we're offering. We took a look at the market and look at where lithium-ion is today, the dominant technology, and where it has some shortcomings. And we've addressed those shortcomings. First, we're completely fire safe. There's no risk of fire propagation, no risk of combustion, no risk of thermal runaway. Second, there's almost no maintenance required. This has really dramatically reduced the OpEx in a project. And it's changed the way project developers, IPPs, utilities think about project pricing. There's no augmentation, there's no oversizing to maintain performance throughout the lifetime of a project. It's quite flexible in its use cases, so it's dispatchable from anywhere from 2 to 10, even 12-hour systems. And most impressively, it's designed to be ultra long life, 30 years, 30,000 cycles, cycling up to 3 times per day. It has very flexible charge characteristics and deep cycle characteristics. And in fact, we're also seeing efficiencies in the mid-80s, which is really on par with lithium-ion when you consider it doesn't require the extra loads that come with HVAC. As we mentioned with the temperature performance, this technology is applicable in many climates and many temperatures. We found it particularly useful in Caribbean microclimates where heat can be quite high and where service and labor can be very difficult. As we mentioned, there's no lithium here, so it's non-toxic. It's composed of minerals sourced on any continent. And best of all, at the end of life, it's nearly fully recyclable. And lastly, it's important to remember that as a startup, there's risk involved, except that with our technology, that has already been proven out over the course of 30 years of space-based applications. Now, we're all here today because we're part of this energy transition, trying to get more renewable energy on the grid or support with ancillary services. And I'd urge you, if you have interest in this technology and want to find out more about Enervenue, come chat with us down the hall. Thank you very much.
Hi, everyone. I'm Caitlin Albertoli, co-founder and CEO of Buzz Solutions. Thanks so much for having us here today. So we may all be familiar, of course, with the wildfires which have rocked California in recent years, or the forced shutdowns, massive power outages that have happened as a result of failed grid infrastructure. We may even know that some of the wildfires have been a result of broken sea hooks or exposed distribution wire coming in contact with vegetation. But what we may not know is that in 2019, 2020, there were 3,700 unanswered maintenance requests that a large California utility had, or that they were capturing 5 million images in 2021 and they're planning to collect 10 million images in 2022. The problem is, once all of that data has been collected, it's still being manually analyzed, with linemen and field technicians stitching through this data looking for faults, causing a huge lag time, which is incredibly expensive and incredibly time-intensive. That's where we're plugging in at Buzz Solutions, providing an AI-powered digital platform, analyzing this data almost in real time, providing highly accurate inspection results. We're looking at things like broken insulators, broken conductors, damage to the structures themselves, such as rusting or woodpecker holes, wood pole rot, and we're prioritizing the anomalies that are happening to reduce wildfires, to reduce forced shutdowns, and to reduce power outages. Currently, we're serving the transmission market, the distribution market, and newly we're expanding into substations as well. We're looking also at some other areas of infrastructure inspections. At Buzz Solutions, our goal is to safeguard the world's energy infrastructure by providing highly accurate anomaly detections. We're today working with several utilities across North America, including New York Power Authority, who's one of our largest customers. We're also working with Newfoundland Power in Canada to help them save about 50% of time per structure, and we're saving about 70% of costs compared to manual analysis. We're now starting to expand, as I was mentioning, into substations doing condition-based monitoring, and we're also starting to expand into the oil and gas pipeline methane leak detection markets as well. So if you have any questions, we would love to answer them, and thank you so much.
Hello, everyone. My name is Zwelim Fundisi. I am the founder and CEO of Empowered Homes. So you guys might not know this, but in South Africa, about 2 or 3 times a day, there are debilitating power outages that last for 2 hours plus a day, which is a big frustration point for the country. It's big for consumers, it's big for economic activity, and we need to do a rapid change with that. Now, in spite of the fact that we are 80% coal-based, so have 4 times more carbon that is emitted compared to California, and there's this huge consumer pain point to change, the country is getting only a fraction of the financing to make it seamless to be able to finance that transition for consumers and businesses and make sure that that problem can be solved. We've been working for the past 2 years now, making it seamless for consumers to get the best solar and storage solutions and recommendations for them and accelerate this energy transition and use the fact that the data we're getting from the systems around batteries and solar can be best used to be able to accelerate the energy transition. Now, because our consumers are starting with needing to make sure that it's backup power, 100% of our solutions do include lithium-ion batteries already, and we're trying to then expand that. So we are now very excited now to then say, in the past kind of year, we now have 90% of our consumers buying systems from us at $10,000 plus without seeing us in person at all. So I've scaled the digital acquisition channel. We're using that data to start doing experiments around second life batteries and selling back to consumers, which is interesting. But what we need to now accelerate is being able to finance these assets en masse and prove the residual value of that, which would be important, but also start doing then things like using that data from consumers to make sure we can verify more of those savings and mass be able to kind of increase things a lot. Now, this is a chart we've created, which is our actual impact from a CO2 impact. And you have on the right there what would happen in terms of kind of California if for the scale we have. And you can see that the scale we have, because we are offsetting lots of carbon, is significantly more and growing. So we're very keen to chat to people who are interested in now solving the climate change problems that are not local, but globally. And be keen to kind of chat to folks then are trying to figure out how we can be able to help financing, but also different technology solutions we can use to be able to scale. Thank you very much.
Hello, everybody. Sorry about missing my cue earlier. That's my fault, but I'll make it up to you in what I hope is an interesting 3 minutes. So my name is Kim Gregory, and I'm the CEO of Renewell. Renewell is, our mission is to clean up and convert 1 million idle oil and gas wells into 1 million hours of clean energy storage. So you might not be used to seeing pictures of pump jacks at a conference like this, but there is a massive opportunity in store here. And what I'm talking about is that the fact that there are 2.6 million idle oil and gas wells in the United States and Canada. And they each have, well, the average depth is about 5,000 feet. So while lots of other gravity-based energy storage companies are building up, we are repurposing millions of holes that go down. So you guys probably know better than most that there's an enormous amount of curtailment happening in grids like Texas and California. We seek to be sort of a solution for the two problems that are happening at the same time: the need for clean energy storage and the ridiculous quantity of idle wells. So what we do is we take a gravity-based technology that seals the well, so no more communication with the oil and gas reservoir. It's now effectively just a deep hole in the ground. And we move a weight up and down inside that well, hence gravity-based energy storage. We control the weight with a mechatronic system, which is just a fancy word for a big regenerative winch. And we lift the weight when power is cheap, and we drop the weight when power is expensive. We are the only net negative energy storage technology out there from a CO2 standpoint, because otherwise these wells are leaking. Up to 40% of idle wells in the United States and Canada are leaking methane. So this is sort of a beautiful purple solution to the situation wherein oil and gas companies have this major problem, some of them carrying billions of dollars worth of cleanup costs that they just continuously punt, and a lot of energy that's getting curtailed, and we could sort of use each of those problems to solve one another. If you're interested in talking more, come find me in the booth over there. We have recently won a grant for $2.7 million, and we're in the midst of a seed round trying to close the last $1 million. So if you're interested, come chat. Thanks very much.
Hello, good morning, everyone. My name is Cole Stites-Clayton, and I'm the CTO and co-founder of Shyft Power Solutions. Shyft is a seed stage energy technology startup. We've developed an IoT hardware and software platform to help enable a clean energy transition in emerging markets, starting in Nigeria. So we got a little bit of intro to the African energy system a moment ago in South Africa. Nigeria is the most populous country in Africa, and actually, for those not familiar with these crazy numbers, projected to be the third most populous country in the world by mid-century, so behind only China and India. And these massive rates of population growth and urbanization have really caused a huge strain on the energy infrastructure, which means that, as in South Africa, there are daily blackouts every single day, forcing consumers and businesses alike to turn to diesel generators as basically the primary source of power to power their day-to-day lives and businesses. So what we're doing is basically supporting a transition to enable power providers in Nigeria to better optimize their assets and improve operational efficiency so that they can reduce the use of diesel generators and really maximize the use of renewable alternatives like solar and storage in this ecosystem. Today, we've deployed our technology to power providers across the country of Nigeria, reaching over 300 homes and businesses who are now able to better understand and improve upon their energy supply. And as we're all aware, this year has been a crazy year in the energy ecosystem worldwide. Definitely, this is hitting Nigeria really hard. Diesel costs have gone up 3 to 4 times, as they have in many countries. But because of this high dependence on generators and diesel power supply, what we're seeing is a really highly increased demand. People are really clamoring for solutions to say, how can we get off of this diesel base to our energy infrastructure and find ways to mix in cleaner alternatives? So we at Shyft are really working to support that, to capitalize on this moment. We are growing our team. We're opening a funding round very soon. So really looking for like-minded partners, investors, employees who are interested in this clean energy transition in emerging markets. And we're right down the hall and would love to talk if that's you. Thank you very much.
Hi, good morning, everyone. We're SQ 4.0, an AI-first company building next-gen solar technology. So both my co-founder and I got our PhDs at Stanford, so excited to be back here. We are backed by some of the leading minds in AI, CEO of DeepMind, Eric Schmidt's innovation endeavors, and a bunch of investors across Silicon Valley, New York, and Singapore, including the Sovereign Wealth Fund of Singapore, Temasek. So jumping into the big market opportunity here, the big sort of $250 billion opportunity of our time is sort of solar. By some count, solar is going to power a third of the world's electricity by 2040, and just as mankind needs more solar, silicon solar technology is about to sort of saturate in efficiency and performance. In this company, we're building next-gen solar technology. The technology we're building is tandem, where a new class of materials called perovskites are layered on top of silicon. The different materials, the different layers absorb different portions of the energy spectrum, drastically increasing the efficiency while just incrementally adding on to the cost of the system. While silicon is going to saturate at 29%, this new tandem technology can go all the way up to 43%. So there's a long S-curve ahead, and so we're in the early days where no one's commercialized this technology yet. Now, sort of what truly differentiates us is the AI angle here. There are 5 to the power of 72 combinations of materials, process conditions, and sort of architectures possible in perovskite silicon tandem technology. So this is more combinations than the number of stars in the galaxy. We are an AI-first company. Our platform AI technology enables us to build sort of new devices in a fraction of the time and cost it takes using conventional methods. And we're the only company in the world today with AI technology for the solar and the broader semiconductor industry. So we're excited. So we will be building the world's first semiconductor device end-to-end with an AI system in our company, and hopefully the world's first commercially viable perovskite silicon tandem solar cells as well. So what's next for us? So we are currently in the R&D phase. We are a fully vertically integrated company, so we're going to go full stack. So definitely relate to all the engineering challenges that sort of full stack companies face here. We're going to build our own solar cells, modules, scale to pilot lines, and build some of the automated gigafactories of the future in our company. So that's us. Do come by our booth to learn more about sort of the future of AI, solar, semiconductors, and how all that's coming together. Thank you.
Yeah, my name is Florian. Thank you to the Stanford family for having us. I'm doing energy at Intertrust, and I will try to take you on a 3-minute journey around energy data. So imagine an electrical energy world in which all data is available, anytime, accessible at any time, anywhere for everyone in a trusted, governed, organized, and secure way. Imagine an electrical energy world in which no data silos exist. Apparently, they do exist today between generation, transmission, distribution, and energy consumption. Imagine an energy world in which AI can be applied on virtual data sets, including data and information from homes, businesses, electric vehicles, the grid, renewables, green hydrogen, the weather, financial markets, and so on and so forth. Imagine an electrical energy world in which sector coupling is supported by a seamless flow of information and data between the electrical, the mobility, and the heating and cooling sector, and within these sectors. This is our vision. This is the vision Intertrust has and is working towards by innovating big data technologies that go apparently beyond what's already existing and enabling AI-based decarbonization strategies. We are owned by a consortium of large-scale energy players with over 100 billion of annual sales and additional corporates from Europe and from Asia. The problem we solve is the missing energy data access, energy data interoperability, energy data sharing, and energy data security across the different segments of the energy value chain, from the energy IoT sensor up to the energy cloud and energy AI applications. A lot of energy here. This includes the seamless sharing of data and information. For sector coupling means the flow of data and information between these 3 sectors that absorb energy that I just described. Why is missing data interoperability a problem for AI-based decarbonization strategies? Because without data, AI is completely useless. There is no automation in the energy system. Without automation, clean energy becomes less affordable. A lack of affordability will limit the growth of renewables and the introduction of green hydrogen. And without sector coupling, no decarbonization. So what is our technology about? We innovate around big data technologies and have created a very unique energy data abstraction layer that reaches down to the IoT device level and can run on any existing data infrastructure. So where is this used already? We can run on any given type of data from energy OT and IT systems and empower use cases in every single part of the energy value chain. Initial use cases we are active in support virtual operation center for renewables like offshore wind, onshore wind, and solar, grid data, grid planning, and foresight tools for grids, EV data load balancing, and EV car data management towards the grid. So what is in our pipeline? We are developing secure data and device environments for virtual power plants, supply chains, asset optimization, energy consumption, and energy customer data management. Visit us at our booth to learn more about what we are doing. Thank you very much and have a great day.
Hi, everyone. I'm David Jaramillo, CTO and co-founder of Verne. I'll start with the bad news. I actually got my PhD at Cal, not Stanford. But my two co-founders are from Stanford, and we got started in the Stanford ecosystem. So Verne is developing high-density storage platform technology to accelerate the transition to a zero-emission heavy-duty transportation industry. So starting with Class 8 trucks, then shipping, then aviation. So the thesis of electrify everything is powerful, but it's not sufficient. There's some industries that require denser fuels, rapid refueling, and other operational constraints. One of those is heavy-duty transportation. Within this industry, one of the most promising fuels is hydrogen. However, even though we're seeing trucking adopt hydrogen right now, there'll be limited adoption. The two storage technologies that are used for transport are gaseous storage. So you go to really, really high pressure, 700 bar, to densify enough hydrogen. Even that is still not energy dense enough, and it's very expensive because of the carbon fiber. So instead, another solution is liquid hydrogen. So that has much higher energy density, but comes at a much higher cost. You have to liquefy the hydrogen, and it's a centralized supply chain. So we have two different solutions, but both have inherent challenges. Verne is developing a third solution that's known as cryo-compressed hydrogen. And you can think of this as the thermodynamic optimum for high-density, low-cost hydrogen. We compress, but not all the way to 700 or 900 bar, just a little bit, and we cool, but not all the way to liquefy. It's really this sweet spot approach where we end up getting liquid-like hydrogen densities without going to go to liquefaction and without a centralized supply chain. So Verne is developing two products shown here. The Verne cryo compressor that will convert hydrogen from electrolysis into this high-density state, as well as storage vessels that are optimized to store hydrogen under these conditions, the cryocompression storage system. We have already built prototypes, and we're working with a few national labs. For example, we did hydrogen validation testing at Livermore National Lab a few months ago. And we're now working on developing our back-of-cab system for a Class 8 truck, shown there. 4-tank system can store over 100 kilograms of hydrogen, doubling the range of what's possible today for hydrogen trucks. So you get diesel-like performance. We got started through Stanford ecosystem, as I mentioned. So our first grant was a Tomcat grant, and we actually came out of the Stanford Climate Ventures course, where we pivoted numerous times and started to focus on heavy-duty industry. And so I want to thank you for your attention, all the support that's there. And then please find me in the booth if you want to learn more about hydrogen or chat about Verne. And so thank you.
Hello, everyone. My name is Jimmy. I am the founder and CEO of EvoloH. At EvoloH, we make electrolyzer stacks to produce hydrogen. Let me start with the team and supporters. EvoloH is funded by Bill Gates' Breakthrough Energy, renowned clean tech investors, and we have won multiple grants from the government. The team includes multiple industry executives, such as the person that led the merchant hydrogen business at Air Liquide and Linde for the past couple of decades, as well as the person who is known as the world's best stack designer, also an executive from the fuel cell industry with decades of experience. And let's go back to hydrogen. You need hydrogen to reach our climate goals. The problem today in the industry is the following. You can make that hydrogen in an electrolyzer, which takes electricity and water to produce hydrogen. And it has two components, the balance of plant, which everyone knows how to make, that's the power electronics, pumps, etc., and the stack, which is the box that makes the hydrogen. That is the problem, availability of stacks. So at EvoloH, we're focusing on making, designing, selling stacks. If you were to deploy a 100 megawatt project today, it's going to take you at least 2 years just to get the stacks. So that is the problem that we're trying to solve. We do not sell hydrogen, we do not deploy projects. We also don't make catalysts or even membranes. We're membrane agnostic. We're very much focused on the stack. How do we do this? We went to the system integrator, the developer, and the EPC, and asked them, what's the cheapest power supply you want to use? What is the cheapest pump? What is the cheapest everything system that you want to use? And we designed the stack for them to minimize their costs. So how do we do this? Number one, we just use steel and plastics, nothing else, just steel and plastic. It is an extremely compact stack in which every single repeating component, without exception, is optimized very carefully for high throughput manufacturing and domestic supply chains. Because of that, not only do we have the cheapest, most compact, most convenient stack, but also we were able to completely redesign the factory that makes those stacks. So we have the cheapest, most convenient stack factory. To give you some numbers, the factory to make those stacks could be at least 4 times cheaper, at least 4 times smaller than anything else you can build today. The stack is at least 1 order of magnitude cheaper compared to the projected cost for PEM electrolyzers or even alkaline electrolyzers. Our ultimate product is going to be a module of 25 megawatts up to 50 megawatts in one single standard ISO container. So very compact. I'm also very proud to announce that we will be opening our Series A in January, hoping to close next summer. Thank you very much.
Good morning, everyone. My name is Gabriella Dweck.
And my name is Kelly Redmond.
And we're here today to talk about palm oil.
Palm oil is the most widely used vegetable oil in the world. It's in over 50% of all consumer goods and represents a significant portion of the biofuel and cooking oil industries.
Unfortunately, the industry is plagued with 3 major challenges.
First, palm oil is the most carbon-intensive commodity in the world, as production often begins with clearing rainforests, accounting for 23% of all deforestation in Indonesia alone.
The second issue involves human rights violations perpetrated by large conglomerates against local farmers, otherwise known as smallholders.
The final issue arises from the mismanagement of massive quantities of agricultural waste produced by the palm oil industry.
So, what does the future look like for an industry that relies on unsustainable practices in the face of rising global demand? Let's examine 2030.
In 8 years, the total addressable market for palm oil will reach almost $100 billion. Indonesia will remain the world's top producer, generating 320 million tons of agricultural waste annually, with smallholders producing the majority of supply. These factors create an ideal landscape for launching a novel production method that is both sustainable and ethical.
That's why Oleo Sustainable Palm Oil Solutions is working to develop a lab-grown alternative that will recycle agricultural waste from smallholdings to cultivate a synthetic replacement for palm oil in the consumer goods and biofuel sectors.
By implementing our solution directly with smallholdings in Indonesia, we can create local regenerative economies, directly addressing the social and economic factors driving deforestation, while also leveraging existing infrastructure to decrease production costs.
Additionally, by recycling the millions of tons of agricultural waste produced by the industry into a fermentation feedstock, we can cut production costs in half and increase yields by almost 30% with fixed assets, all while eliminating the need for deforestation and drastically reducing carbon emissions.
We recognize that we cannot implement our solution alone. That's why we formed a strategic partnership with the Biorenewables Development Center, a world-class technology provider, to facilitate the production of our synthetic alternative.
We have also developed relationships with 7 associations of smallholdings in Indonesia, each representing hundreds of farmers who are excited to partner with us to deploy our solution.
Our technology prioritizes both the planet and the people who call it home. Not only can it improve the livelihoods of millions of smallholders globally, it can help preserve our precious remaining rainforests and decrease greenhouse gas emissions. Oleo SPOS is combating the present climate crisis, but our vision doesn't end there. Our commitment to creating sustainable energy sources and local regenerative economies create the building blocks for a sustainable and equitable future.
Thank you. We are Gabriella and Kelly, the co-founders of Oleo Sustainable Palm Oil Solutions. Come visit us at our booth today to learn more.
Hi, my name is Akash. I'm the co-founder and CTO of Working Trees, and I'm going to start us off with a question. How many of you have heard that planting trees is good for the environment? Sure, it gets a lot of press, but I'm unfortunately going to tell you that it doesn't really happen at a meaningful scale. And I'm going to tell you why in the next 3 minutes. But a prerequisite of that is understanding quickly how a carbon market works. So you're probably part of a company or have heard of a company with a net zero commitment. This means they've set a date by which they'll effectively reach zero greenhouse gas emissions. First, they do this by reducing the emissions in their own practices, but there's always almost some leftover fraction that they can't reduce by curtailing their own emissions. So they pay other folks, entities or individuals, to sequester that carbon on their behalf. That transaction is all a carbon market is. Now, buyers of carbon offsets really need two things: quantity and quality. On the quantity side, the supply of carbon of high quality carbon offsets is much lower than the current demand. And on the quality side, these companies need to be sure that their finances are going towards proper solutions that aren't going to land them on the cover of Bloomberg for a greenwashing claim, their greatest fear. But you have to make it work for the farmers and the ranchers who manage the majority of the habitable land on Earth. And they also face significant challenges. Both of them are related to costs. The first is the cost of establishing trees. Trees provide wonderful benefits in agricultural operations. They reduce the erosion of the soils. They increase the water retention capacity. They provide fodder for livestock. They control wind. They have so many of these wonderful benefits, but those benefits come years in the future. And it costs money to plant trees now. So we have to bridge that gap. And carbon finance is a compelling way to do that for our land managers. The second barrier that land managers, farmers, and ranchers face is monitoring. Monitoring of their carbon offsets and their carbon in their agroforestry and nature-based carbon solutions. The costs of monitoring these systems are currently prohibitively high for average-sized landowners to participate. In fact, it doesn't really make economic sense for landowners with less than 5,000 acres right now. And that's because the way that these systems are monitored are people, boots on the ground, traveling to remote locations with tape measures and calipers. So we essentially provide two services to overcome all of these barriers. By pairing ranchers and farmers with offset buyers of carbon credits, we can provide financing for them to establish these agroforestry or planting trees on agricultural lands at $0 down. And by equipping them with the technology that they need, that's already in their pockets on smartphones, to cheaply, accurately, and quickly monitor the amount of carbon being stored on their lands, we can reduce the amount of costs required for them to establish and monitor their agroforestry installations. So we at Working Trees are solving these problems. We have launched the first agroforestry carbon project in North America, to the best of our knowledge. We have a guaranteed buyer to purchase the carbon credits. We've built a phone application, and we're testing the accuracy with our partners at Virginia Tech, and we've received some funding from Stanford University and the Department of Agriculture to keep going. So if this sounds interesting to you, if you are an individual or part of a company that's looking for looking to learn about high quality carbon offsets, come find us in our booth. You can check out the app, you can download it, or visit workingtrees.com. Thanks very much.
Hello, my name is Benjamin Wang, and I'm an Autodesk postdoctoral fellow in the Department of Mechanical Engineering, and I'm happy to tell you about the Nitrogen Company. Our journey was enabled through a seed grant through the Tomcat Center and the Woods Institute for the Environment. It originated out of a plasma technology developed out of Professor Mark Capelli's Stanford Plasma Physics Lab. In the past 6 months, we've also been fortunate enough to receive a generous support from the Stanford Sustainability Accelerator Program. We would like to thank all of these programs for their continued support. Nitrogen fertilizer production is currently strained due to world conditions, and because of this, food insecurity is on the rise in many countries. As most of you already know, current methods of fertilizer production is also very damaging to the environment. Our goal is to engineer a highly scalable, fully decentralized, and sustainable machine to produce liquid nitrogen fertilizer using only electricity, water, and air. Through our need-finding exercises with small farmers, we have designed a scalable, low-cost modular system that allows for on-site incorporation into fertigation units, as well as using the same modular units for large-scale production. A significant percentage of nitrogen in nature is produced through lightning strikes in thunderclouds. This produces a hot plasma that generates conditions ideal for forming NOx in the atmosphere, which is soluble in rain and provides the nutrition that Earth's surfaces use in the form of nitrate ions. This hot plasma from the lightning is necessary to break strong nitrogen and oxygen bonds. In our system, we use a near room temperature plasma with very hot electrons to break these chemical bonds without the heat requirement. These plasmas are very similar to the types used in manufacturing semiconductors. We have progressively engineered our device from a simple 20-watt benchtop scale experiment to a production-ready 30-kilowatt prototype mobile unit that is more than 1,000 times in size based on power capacity. Through our efforts in design for manufacturability, we have completed limited manufacturing runs that utilize modern manufacturing methods, including thermoforming and extrusion, to significantly lower our capital costs in our plasma reactors. We are very close to cost parity in terms of production with clean electricity sourced from photovoltaic farms. Right now, we're looking for partners to help us scale our technology and introduce this to various markets. We have our demonstration unit on site today making nitrogen fertilizer, so please come check us out. Thank you very much.
That concludes our lightning panel for this morning. I just want to take a minute to say thank you to each of you. I feel very proud to work for an institution that doesn't just educate our students, but provides the tools and the pathways that allows them to scale their incredible technologies and really work towards mitigating climate change in a very real, tangible way. So with that, please join me in thanking all of our panelists one more time, and I will hand it back to Jimmy.